Hello, I am Harmon Diego, most caliente of Caliente Magazine, 1998. And I hope that's not copyrighted. As you know from physics class, an object at rest will remain at rest until acted upon by an external force. This means that if an object is not moving, it will continue to not be moving until something else makes it be moving.
I hate this guy!
As you could see, when I was sitting there like a lazy bum, waiting for my friends to text me back, my little sister was often rude to me. She came up, she tripped me, she pulled me over. That I did not appreciate, but she had to overcome my inertia in order to knock me over. As you also must have heard in physics class, an object in motion will continue to be in motion until acted upon by an external force, causing it to no longer be in motion. As you could see, my little sister was playing with Perry the platypus, who she loves very much. Anyhow, I walked through and I saw her throwing Perry in the air. And I thought to myself, Perry is coming to rest in her hands and also at his peak of flight. He's coming to rest, and what is making him move? First, she is throwing him into the air. This gives him motion, and he will remain in motion until acted upon by an external force, which he was. Gravity and air resistance both pulled him down. Perry cannot fly. But as he comes to rest at the top, he begins to move again. Gravity pulls him down. Maybe Perry can fly. I do not know. Anyhow, as he was coming down, I knew what I could do to get revenge. I smacked Perry out of the air. Perry flew. Hey, where did Perry go? Newton's second law is the law from which we derive the fact that force equals mass times acceleration. We have all learned this many times. Anyhow, as the force acting upon an object goes up, the acceleration will also increase. Who knew? Also, as the mass of an object grows, the acceleration caused by that amount of force will go down. In this example, you will see that the great force upon an object with little mass will cause this object to accelerate greatly and move quite far. As you saw in this example, my little sister was playing Legend of Zelda Twilight Princess next to her beloved Perry the Platypus. I saw this, and I knew that it was my chance to strike first. I knew what I must do. I went and I kicked Perry the Platypus right in the bottom, and then I kicked Caitlin over. That was satisfying as well. In this example, you will see that a somewhat weak force will not cause a very heavy object to accelerate quickly or move very far. Oh, I should have known she would strike back. She wanted revenge. So when she saw me and my precious collection of most treasured toys from my childhood, she kicked it, and then she turned and kicked me. But luckily, she does not have much force, and I have plenty of mass. Anyhow, we saw that her sweet little kick could not move this mass. In those past two clips, we saw that force equals mass times acceleration, Newton's second law. Now this Newton, he had a third law. Yes, a third law. You could tell he played on the big kids' playground in the physics world. Anyhow, this third law states that for every action there is an equal, opposite reaction. Now, everybody has seen a set of Newton balls sometime. You know, there's the set of the 4 balls and the one goes... It's harder than it looks to do with your hand. Don't judge me for that. But, have you ever seen such a thing happen in a real life situation? No, you haven't. Because unless you're on iCarly, there's never just a big set of Newton balls lying around. Anyhow, I'm going to show you when this happened in real life. Holy headache, Batman. Did you see that? Things finally came to a head between me and my younger sister. Actually, it didn't really come to a head. It was more like coming to a fist. No, my head came to the fist. Anyways, we went mano a mano to settle our well, we didn't go mano a mano. We went mano a cabeza to settle our differences. And it turns out we are quite evenly matched. Because for every action, there is an equal and opposite reaction. And that is why there was no conclusive winner. As you saw, the action was her fist coming to my head. The reaction was my head jerking back. And then the action was my head jerking forward. And her reaction was the fist jerking back. Oh, it was tense. You would not believe how tense it was. It was quite tense. Believe me, it was very tense, even though she began to laugh at the end. Anyways, it was tense. But with this example, I give you, ladies and gentlemen, Newton's third law. So there you have it, ladies and gentlemen. A quick and easy learning guide to Newton's 3 laws. You will never forget these laws ever, so long as you live and have this video on a flash drive in your pocket. Newton, he had a set of very impressive balls. No,